Lesson 8-7, describe cross sections. In this lesson, you're going to learn how to determine what the cross section looks like when a three-dimensional figure is sliced. Take a look first at the solve and discuss it. How could Mrs. Mendoza divide the ream of paper equally between two art classes? She has a paper cutter to slice the paper if needed. What will the dimensions for each sheet of paper be once she has divided the ream? How many sheets will each class receive? So this is a typical problem that involves a ream of paper. In case you don't know, a ream of paper has a total of 500 sheets. These are the packs of paper that we use in the copy room before we make copies of worksheets. So these are the ones that are sealed up and wrapped up, and they're wrapped in groups of 500 sheets. So let's think about it. Here you see the dimensions of that paper, okay? So each sheet of paper is 8.5 inches along the top and the bottom, and 11 inches along the left and the right side. If she wants to split that ream of 500 sheets of paper between two art classes, how many sheets of paper will each class receive? Well, one of the things that you could do is you could take that ream of paper and divide it into two groups of 250 sheets. Okay, remember the whole ream has 500 sheets in it. Each of these packs of 250 would still have the dimensions of the original ream of paper, which is 8.5 by 11. Is there any other way that she could cut the paper using the paper cutter and still divide that ream between her two classes? And the answer is she definitely could. So let's take that same ream of paper that has 8.5 on the top and bottom and 11 along the left and the right side for dimensions. And instead of cutting the paper so that we have two stacks of 250 sheets that are the same size as before, let's take that same stack of paper and use the paper cutter and cut it in half. Now, the question is, how many sheets are in each half? And what are the dimensions of that paper now? Well, it still has a length across the top and bottom of 8.5 inches. But now instead of it being 11 inches along the side, it's half that distance, or 5.5. And how many sheets of paper are in that stack? Well, you started with a stack of 500 sheets, and you cut it in half from top to bottom, so you still have 500 sheets. They're just a lot smaller. Could she cut it any other way? And the answer is yes. What if she cut the paper in half and did so in this direction? Would there still be 500 sheets in each stack? And the answer is yes. But what would the dimensions be of each of those stacks of 500? Well, this time, the left and the right side would still have the dimension 11. But what about the top and the bottom? Instead of 8.5 inches across the top and the bottom, each of those would have 4 1/4 inches. So the dimensions on those two would look quite different. In this lesson, we're going to learn about how to take figures and cut them to look at the inside shapes that they make. Now let's take a look at example 1. Describe cross sections of right rectangular prisms. Rachel and Francesca went to a restaurant that serves rectangular bread rolls. Each sliced her roll in a different way. What do the cross sections look like? So what I see here is a vocabulary word. and that is the two-dimensional shape that is exposed when a slice is made through a three-dimensional object. So take a look at how they divided up their bread rolls. Rachel's bread roll is on the right, or I'm sorry, on the left. And she slices it from top down to the bottom of the plate. So she cuts her bread roll basically in half, in two parts. So when she makes that slice, and you can see here in the picture, that this space right here in green is the slice that is made through the middle portion of that roll, where the 3 inches is the top and the dimension of 2 inches is the side. So her top and bottom are the 3 inches and the 2 inches is her side. So the cross section is a rectangle that is 3 inches by 2 inches. Remember that this cross section, as you cut from the top of a figure, excuse me, is parallel to the front and back faces. So it has the same shape. So in this case, you see the front shape here outlined in blue, and you see the back also outlined in blue. And this green shape here in the middle is that face that is parallel to the other two. Think about the way that Rachel sliced that bread as being the way that you would see a loaf of bread in the store, where each slice of the bread in the loaf makes the same shape as the front and back of that bread loaf. Okay? So this is just like a loaf of sliced bread from the store. Then we have Francesca. Francesca selected to cut her bread horizontally, and that makes it perpendicular to the front and the back face. In other words, she sliced it through the middle of the roll, through the sides. She did not cut through the top and the bottom. This is similar to how you see hamburger buns sliced and hot dog buns. Okay, they are sliced in this manner. So when you look at Francesca's cross section here, hers is actually parallel to the top and bottom faces, and it has the same shape as those faces. Okay, her top face up here, and then the bottom face, you can only see part of it, like that. So when you look at her cross section, what you're actually looking at is the 4-inch side is the side of the figure, and the 3-inch is the front and the back. Okay, but this cross section is also a rectangle, and it has the same dimensions as the top and bottom of that figure. Now let's complete the try it problem. Zachary made a vertical slice that was parallel to the left and right faces of a bread roll. So he cut his bread roll similar to how Rachel cut hers. He cut it vertically from top to bottom. What was the shape of the cross section, and what are its dimensions? So what shape does this make when Zachary cuts his bread roll from top to bottom? The shape is a rectangle. And I know it's a rectangle because the dimensions of this rectangle are the same as the dimensions in the figure. So this is 4 inches along the top and bottom of that cross section, and it's 2 inches tall, like you see in the figure. So it is a 4-inch by 2-inch rectangle. Now let's try example 2. Describe cross sections of right rectangular pyramids. Kenya made a sandcastle in the shape of a right rectangular pyramid with a height of 9/10 feet. Okay, so remember that height right here is from the top of the pyramid measured all the way down to the base of that pyramid. A, if Kenya sliced the castle horizontally, parallel to the base, what would the cross section look like? Well, in this case, cross sections that are made from slicing that pyramid horizontally would all be in the shape of rectangles, okay? All be in the shape of rectangles, and each one would have dimensions that are smaller than the base of that pyramid. So unless we know how high up we are in that cross section, we don't necessarily know what the dimensions are. What we know is that it's going to be smaller than 7/500 feet for each of the front edges, and it will be smaller than 6/10 of a foot going up to those smaller rectangles. B, if Kenya sliced the castle vertically through the top vertex, so the top vertex is that top point where all the faces come together. Okay, remember that slice is going to be perpendicular, so it's going to come straight down to the base of that pyramid. If she makes this slice here, intersecting the edge that's marked 7/500 feet, that's this edge right here, front and back, what would the cross section look like? Well, in this case, the cross section is going to be a triangle, specifically an isosceles triangle, because there are 2 sides that are the same. So it is an isosceles triangle because there are 2 sides that are the same. The height of that triangle is the same as the height of the pyramid, which is 9/10 of a foot. And the base length, that means this bottom side here, the bottom side of that triangle will be the 6/10 of a foot, that is the same as the base length of the rectangle that makes up the base of that pyramid. Now for example 3, solve problems involving cross sections. A truck needs a metal divider that separates the refrigerated part of the truck from the dry goods. What should the divider look like, and how many square feet will the metal divider be? So let's take a look at the truck in the picture. The dry zone is going to be the back part of the truck, right here. I'm going to move my coloring in just a second. While the refrigerated zone is going to be up front. And between the two is going to be a metal divider that separates them, because you can't have the refrigerated section and the dry zone together. So the first thing that we need to do is look at this piece that makes up that metal divider and determine what those dimensions are. So I'm going to erase my coloring here so we can go back and look at those dimensions. So the metal divider, again, is this piece right here. Okay, and inside the truck, we have that metal divider splitting that truck into 2 parts. The distance across the bottom of that metal divider will be the same as the distance across the bottom of the truck, which is 8 feet. The height of that metal divider will be the same as the height of the truck, which is 10 feet. So to find the area of that metal divider, we would multiply the length times the width. So the metal divider will have an area of 80 square feet. Now complete the try it. Try to draw a sketch of the cross section that is created when a vertical plane intersects the top vertex and the shorter edge of the base of the pyramid shown. So the shorter edge here is where it intersects. So what are the dimensions and then the area of that cross section? So let's take a look. In the picture, we see that we are drawing a triangle. Let me start that triangle over. Next, we need to look for the dimensions. Since the triangle is cut from the top through the shorter edge, which is the one marked 3 inches, then that means the bottom edge of this triangle in my cross section has the same dimension as the 7 inches along the bottom of the triangle in the picture. Next, we need to look for the height. Since the height of that pyramid is 4 inches, then the height of our cross section is also 4 inches. Now to find the area of a triangle. Hopefully we haven't forgotten that. But remember, area is 1/2 times the base times the height of that triangle. So I'm going to take my 2 dimensions and multiply them, and then I need to take half of that. The base is 7 and the height is 4. So the area is 1/2 times 7 times 4, which is 28, which makes the area 14 inches squared.